A very good evening. So, so firstly, we will make sure the screen is visible to you and I'm audible to you. If I am so, just yes, very good. These thumbs up will work. Yeah. Okay. Okay, Pushpa, I got this. So here we are with our lecture number 2 of gravitation. ठीक है. Gravitation ऐसा नहीं है कि आपने पहले कभी नहीं पढ़ा. You have kind of knowledge about it in your ninth class. It is not lecture number 1, it is lecture number 2. Although conceptually it is lecture number 1, because in the previous lecture we have not discussed so much about this. Like for gravitation, we have discussed about the J means. And I hope you are all are remember that you are not dreamer, you are the aimers. Huh? Okay. So I welcome you all in this lecture. So what we are going to study today, that is very important. So in gravitation, what is the aim for today? Firstly, we will learn about the Newton's law of gravitation. Okay. Then principle of superposition, we are going to discuss. And then gravitational field intensity. After that, gravitational field strength. Okay. Some of the numerical we also do in the principle of superposition. Okay. Got it? Okay. Just a second. Huh? Yeah. So firstly, we will learn Newton law of gravitation. Okay. Then the principle of superposition, gravitational field intensity after that, and in the last, gravitational field strength. Okay. So without wasting time, let's just get started with the lecture. Huh? So here we are with the Newton's law of gravitation. Okay. This law is formulated by Newton, but it is not that after the discovery by Newton, this law came into the presence. No, this law is present then and now. Okay, without before it will discovered by Newton, it is present because gravity is always there. So this law is also given. Okay, the Newton's did his job just by formulating it. Okay, and that is a big task also. Got it? So here we are not going to derive the gravitational law, yeah, Newton's law of gravitation, because the derivation part is too big and that is not in your syllabus also. So here we are seeing the conceptual fundamental of this law, okay, on which fundamental this law is based upon. Got it? So firstly, I will select the color of pen. Now, let me tell, is this visible to you? This color is visible to you? Just give me the thumbs up or write this thing in the chat box. If not, I will change the color of the pen. Okay. So that in case it is more visible to you. Got it? So Newton's law of gravitation. Statement of this law is, and note it down, no? Statement. What is the statement of this Newton's law of gravitation? Newton's law of gravitation says that each and every particle which has some mass present in the universe trying to attract the another particle having some mass. So there is a force of attraction between each two particle in universe which are present in the universe. So every particle present in the universe will feel and experience a force of attraction by another particles. Okay, like this gravitation term is defined as the tendency of a particle to be attracted by the another particle. So that tendency, whether it is not getting attracted or not, that is not the final task. If it is getting attracted, good. If it is not getting attracted, then we cannot say that gravity is not acting there. Gravity is also acting. Gravity is always acting. But the amount of force experienced by that particle is not sufficient enough so that it can pull the another object. Like for an example, if you try to pull, if you try to lift up your pen, can you lift it? Yeah, easily. Because the mass, amount of mass of your pen or pencil is very less. So it can be easily liftable. Got it? But when, if you try to push or pull a car, a passenger vehicle, can you do it? No. I'm not supposed to say that, but none of you are able to do that until and unless you are not sitting inside the car. Huh? That can give the movement to car. Now you can just start the key, okay, switch on this and put it in the gear, take off the accelerator, then car will move. But in practically, if you try to push it by your hand or pull it, it is very, very, very difficult you to push it or pull it. Okay. So that is how, but the tendency, you are tending to pull it or push it, na? That is important. And here in universe, each and every particle has that tendency, okay, has that tendency to pull another mass particle. Like for example, you always have seen that sparkling stars, that falling star you will see. Huh? This is nothing but this is not a star. That's not star. These are the meteoroids or asteroids, which comes into the contact of Earth, okay, in the atmosphere of Earth. So what will Earth do? Look, here is the Earth. This is the Earth, our Earth Mama. Okay. And this is the particle mass m, which is the asteroid, you can say. Okay. It is coming because this Earth has greater mass. Mass of Earth is greater than this mass of asteroid. So it is pulled by Earth, although it is also pulling the Earth. But tendency is there. But since it has less amount of mass, it has greater amount of mass, so it will be attracted towards the Earth. Okay, got it? Means each and every particle is trying to push, trying to pull of another mass. So the statement of Newton's law of gravitation is each and every particle try to try to attract the having some mass. Write it here, having some mass. Having some mass. Try to attract the another particle or object in the having some mass in the universe. In the universe. Okay. So each and every particle has that tendency to attract the another particle. So write it here. The tendency of any particle any mass particle, I will say, any mass to attract another mass, another mass is termed as what? The chapter that we are studying is termed as gravitation. Gravitation. Okay. And the force experienced by these particles and the force of attraction experienced by the mass particles termed as what? Gravitational force. Gravitational force of attraction. Okay, got it? Now, move on to the Newton's law of gravitation. So Newton's law of gravitation says that the force of attraction, the force of attraction between two mass particle is first directly proportional to directly proportional proportional to product of their masses, product of their masses, which means, let me just change the color of it, that force of attraction is directly proportional to m1 m2. If there are two particles, m1 and this is m2, and the separation between them is small r. Okay, so the first statement is this. Got it? Now, the second statement, I will write it here. I hope you have noted down or taken the screenshot of it. So I'm writing it down here. Okay. Just a second. The second statement is the force of attraction, force of attraction is directly proportional to what? The square of the distance between them. Not directly, it is inversely. Between them. So what is the distance between them? It is r. So f is directly proportional to 1 upon r square. Okay, this is equation number 2. By combining combining equation 1 and 2, what you will get? It is F is directly proportional to m1 m2 by r square. If you remove this proportionality sign, so it will be removed with the help of a constant, which is F is equals to capital G m1 m2 by r square. Okay, got it? This is your force of attraction. I hope you got this. Here m1 and m2 are the masses of the particle and r is the distance between the center of the particles. Okay, and this is F. F is the force of attraction, which is the gravitational force of attraction. Got it? This G here is this capital G. I'm writing it here. Capital G is universal gravitational constant. Universal gravitational constant. Okay, got it? Now, so if anybody has doubt in this, that how we have derived it, how the proportionality sign have removed, what are the statement are not clear to you, you can ask it. Okay, you can write this thing in the chat box and I will re-explain it for you. Okay, got it? Yeah, Molya. Who have raised the hand? Yeah, Rashmi, I got this. It is inversely. Uh, so I hope this is clear to you. Okay. Now move on to the next slide. Now, properties of gravitational force. Now the properties of gravitational force are: first, it is independent of the medium between the particles. Okay. So if the particle is present in water and another particle is present in air and it is trying to pulling it, so the water will play no role in that. Okay. So this is a constant force which only depends on the product of masses and the distance between them, square of the distance between them. Okay. So it is independent of the medium between the particles. Okay. Next point, it is always attractive in nature. Okay. You have seen the magnet. It can attract or repel both. But this force of gravitation is always attractive in nature. It is its property. Okay. It will always be attractive. Means it's always trying to attract the another particle. Got it? Now the next property. Yeah. This law is true for like this: F is equals to G m1 m2 divided by r square. This r is valid up to the intermolecular distances to the interplanetary distances. Means if you are taking the particle which is inside the material, like you are talking in terms of atom, yeah, the atom will also feel this gravitational pull, and they also apply, the one atom is also apply the gravitational forces of attraction to the another atom. I'm not talking about electron, proton and neutron. These are the fundamental particles. I'm talking about the atom and molecules. So one molecule applies the gravitational force of attraction to the another, which means that this law of gravitation is valid for intermolecular distances. Okay. And interplanetary, yeah, obviously, if you take the object like Earth and Sun and Moon and another planets, so it is valid for that also. Okay. So distances will play no effect to it. Although the magnitude of the force will reduces when you talk about the smaller masses like the atoms or molecule, and it increases in magnitude when you talk about the bigger mass particle like Earth, Sun, and other planets and asteroids present in the interstellar. Okay. Now, next point, it is the weakest force in nature. Okay. To try to remember it, it is the weakest force that we have found in nature. But one of the application I will show you that it is behaving as the strongest force there. I will discuss it after the completion of this property. So it is the weakest force in nature. The next point is it is conservative force in nature. Now this is the point you have, I think you have covered in work, energy, and power. Okay. The conservative force is that force which has a zero work done in a round trip. So if gravitational force is working and the path covered by it as a circle or round, okay, means it came from where it started. So that the work done by this conservative force is zero then. Okay, got it? It is very simple to understand. When you go to the upstairs and you go to the first floor and then you try to coming down without using stairs. So the energy that you have spent in coming up will be restored when you are going down. Okay. The energy in going downward, you are using that energy you have conserved. Okay. Although the energy of yours will be very much be less when you fall down. Okay. But to understand this, the work done is zero because you have gone upward and then you will move backward. If it is similar when you throw a ball in your hand, vertical direction, so it is goes up in the effect of gravitation, and the gravitational pull constantly are working on it, and then it moves back with the same amount of force. Got it? So the work done by force is zero because to the same position. Let's say this height is h and this force mg is acting in this, the gravitational force. So the what is the work done in upward motion? Mg force is acting in this direction and it is covering a displacement in opposite direction. So there is an angle of 180. So work done we have F dot D, which is FD cos theta. F we have mg, D we have h, and cos theta we have cos 180. What is the value of cos 180? It is -1. So mgh -1 into minus mgh. For the downward motion, again the force mg is acting and it is covering a distance or displacement in the same direction in which the force is applied. Yeah, Rashmi, very good. So work done here is F dot D cos of theta. Now the theta here is 0 degree. So cos 0 is again 1. And F here is mg, D here is h. Work done here is mgh. If you try to calculate the total work, it is W1 plus W2. Work done in moving upward this ball and work done in moving downward this ball. So upward may it is minus mgh and downward it is mgh. You will see the work done here is 0, which means the force which is acting on the ball, which is doing the work, is conservative in nature. Got it? So this is the property of it. Let me just rub this surface. Just a second. Okay. यहाँ तक का सब क्लियर है? अब तक जो भी पढ़ा है, each and everything is clear to you, Rashmi? The next point here is it is an action reaction pair. Okay, action reaction pair, which means if this is the earth I'm taking the example of Earth and Moon, and this is Moon. So if Earth is applying a constant attraction force on Moon, constant attraction force, this is the force applied by Earth. So the Moon will also apply the same force on Earth, which is force applied by Moon. So we can say that force applied by Earth is equals to force applied by Moon. So this is the action reaction pair, and it is also can be understandable by the Newton third law. Newton third law says that each action has opposite and equal reaction. So Earth is applying an action to the Moon, so Moon is reversing back in the reaction. Okay, so Moon is applying a reaction to it. Got it? So this is also a property of gravitational force. Now it is a central force also. Central force means it is always acting towards the center of the particle, or more specifically I will say it that it is always acts towards the center of mass. Central force means it always acts it always acts along the line along the line joining the center of mass of the objects, yeah, of the particles. For spherical particle, we assume that all the mass present on the center. So Earth is also be considered as a sphere. Okay, so we can assume the mass of Earth at its center. So for example, if this is Earth and Moon is also a sphere, this is Moon. So the direction of this force will be from lines joining center of Earth to the center of Moon. Okay, got it? So that is why this is termed as the central force. I hope you got this. Huh? Okay. Now I am blanking this, that I want to share some information with you. More information. More information. Information about uh, Newton's law of gravitation. Okay. So if you write it in the vector form of Newton's law of gravitation, NLG. Okay. So it is F vector is equals to G is a constant, mass is a scalar quantity divided by this R vector square multiply with R cap. R cap is the unit vector. R cap here is the unit vector. Unit vector of R. Okay. So let's say these are the particles we have. One, this is particle number 2. So this is the line joining the center of it. In this coordinate system, this particle has a position vector R1. This particle has, with respect to this origin, this position vector R2. So the resultant vector will be this. This is R2 vector minus R1 vector. Okay. So the force of attraction is acting along this vector. Okay. This R1, R2 minus R1 vector. Got it? And this R2 minus R1 vector you can assume as a vector like vector R. So that is why I have mentioned here. You will also put it as that R vector is equals to magnitude of R vector multiply with its unit vector, because unit vector is used only for the direction. So the vector has complete its value. It is the magnitude multiplied by the direction vector. So this will result in the complete vector. So you will put it as like r cap is equals to vector r divided by vector divided by magnitude. So if you put it in, this is equation 1, put it in equation 1. So the f vector will become gm1 m2 divided by, this is the magnitude, this is the magnitude, okay. This will become r cube, because r cap is r vector by r. So this r will multiply with this r square, so it will become r cube dot r vector. So these are two forms of vector representation of Newton's second law. Take the screenshot of it or just note it down. I'm waiting for 10 seconds, waiting for 30 seconds to note it down, because this screen then is not visible to you then. Okay. So just take the screenshot. I'm waiting for 30 seconds to you to write it down or take the screenshot. जल्दी लिखो भाई. I hope this is clear to all of you. Huh? If you have any kind of doubt, you can ask. Okay, you can write this in the chat box. Whatever kind of doubt you have. Now, this is our Newton's law of gravitation. It is the application of Newton's law of gravitation. First application is it helps us to determine the mass of Earth, Sun and Moon and other planet also. Okay. Other planet present in the solar system. Other planet also. Other planets. Okay. Like Jupiter. Okay. And Mercury. All the 8 planet that we have in our solar system. The next application of this law is to determine the motion of moon around the earth, that how and when the moon will complete its circle, complete its revolution, what path it is taking. Okay, these are very important, because when we launch a satellite, we have to calculate the exact position where we want to launch it. Okay, where we want to place that satellite. So these are very important for the calculation of that. Okay. Now the next application is to describe the motion of planet around the sun. How the sun is revolving, how the sun is also revolving, but how the planets in our solar system is revolving around the sun. What path they are taking, how much time they will take to complete one revolution. These all information also be calculated with the help of Newton's law of gravitation. Okay, I will discuss it in the next upcoming lectures, then how we can determine the motion of a planet around the sun. Okay, the next application of this concept is to describe the tides due to sun and moon. Like we have seen the tides na in our oceans. We have seen in the sea, sea means sea, samudra. Okay. In sea or ocean, we generally see that there are high tides are coming, low tides are coming. What are they? They are just the gravitational force applied by the moon and sun. So they want to lift up that. Okay. Look, this is the earth, which is 70%, 80% of water. Okay. So if there is water, like say, and this is moon. So what does moon applying the gravitational force? So this water trying to go to moon, but due to the gravitational pulls of earth, it remains there. Earth then attract it towards it, towards the center of it. So these high tides are formed. Okay, on the beach you will see these tides are coming. So these are the tides created by moons and sun, by the gravity of moon and sun. Okay, so now the next application is, it also helps us to discover the new stars and moons. Okay, this is not in your syllabus, then how we discovered new stars and moon. And if you want to take a expensive telescope, and in the night you will observe the planets and all. Okay, you will find some new stars and moon there, definitely. Got it? And you will name them according to you. Okay, like Bhavna, I think Bhavna will discover a new moon. Okay, by the telescope that he has spent a lot of money. So the name of the moon, when Bhavna discover it, will be Bhavna. So we will have a new moon named Bhavna. है ना? Okay. One day that will going to happen, I hope. Okay, Bhavna? Yeah. Now the principle of superposition. What is that? Do not confuse by the name of it. Okay. Like this is your friend. Okay. This is a friend of yours. And you have one of his hand is tied with a string. Another hand is also tied with a string. Here you are, and here is your another friend. Okay. So they are trying to pull it. Now, for example, you are there and your friends is trying to pull your hands, which is tied by a string. So tell me, this is Ramu, this is Ganesh, and this is Shamu. These are very famous names, so I have to get. So Ganesh has a two friend named Ramu and Shamu, and they are constantly pulling his hand, which is tied by a string. So if I ask you, if you are the Ganesh, okay, assume yourself there in the place of Ganesh. So what do you feel? A pull. But tell me, if on this side it is Shamu and this side it is Ramu, so this pull, the pull of this hand that is experienced by you, does it affect by how much force Shamu has applied this hand? No. Ramu plays its part, Shamu play its part. They are totally different. Okay. So the principle of superposition said that the force, I hope you are clear with this. The principle of superposition says that the force applied by a mass, applied by a mass particle will not be disturbed by the force applied by another particle, another particles. Okay, let's say there are, this is m1, this is m2, m3, m4, and there are n particles are present. So the force applied by this m1, so we will see the force applied on M1. So this M3 will apply a force on it and trying to pull it towards the line joining the center of them. M2 will also try to pull it. M4 is also trying to pull it. And each and every particle trying to pull it. But the force applied by the M3, which is F M3, force applied by M3 on M2 is independent of independent of the force applied by M2 on M1. So these forces are independent of each other. They will not get disturbed by the amount of force that is applied by another particle present in the system. This is the principle of superposition. Okay. The next statement of it, or you can say, or the net force experienced by a particle is the vector sum of all the forces present in the system. Present in the system. Okay, got it? Which means that F, if I say this force applied by M2 is F2, by M3 it is F3, by M4 it is F4, and by Mn it is Fn. So we can say that the net force on particle 1 is equals to the F2 plus F3 plus F4 plus up to Fn. And this is the vector sum. So you have to take care of the direction also. Got it? So this is the principle of superposition. Got it? Have any kind of doubt? You can write this in the chat box. Now move on to the next slide. So this is the numerical. It will help you to understand the principle of superposition. Principle of superposition is a concept. It's such a concept that is not so much theoretical. It is practical to understand. Okay. Now I will solve it for you firstly, and the next question you will solve by yours. Okay. There are three uniform solid sphere, each of mass m and radius r, are touching each other. So find the forces of attraction on any one due to other two. Like say these are the particle which are touching each other. Okay. I will draw it here. This is the particle. This is another particle. And this is, firstly we will draw that particle which is present below. And then this particle. Okay. So this particle ka mass is m and radius is capital R. This particle also has mass m and radius capital R. And this particle also has mass m and radius capital R. They are touching each other. You will see they are touching each other. There is no such combination other than this by touching them. One of you are thinking about like this. But here, this one is not touching this three. Okay. So the combination is this. If you try to connect their centers, these are the centers line joining them. Okay. This triangle plays a very important role. Now, what do you need to find the forces of attraction? Like I am saying this is a particle 1, solid sphere 1, this is 2, and this is 3. Okay. Because the forces of attraction are always acting towards the line joining the center. So that is why I have drawn this triangle, the line joining them. Okay. So we are interested in this triangle only, because these particles you can assume to be a point mass, and all the mass present on the center of it. That is why you can assume it here. This is mass m, this is also mass m, and this is also mass m. What is this angle? Look, this length is radius of this sphere, this length is the radius of this sphere. Same goes for this combination, and same goes for this. So this is 2r, this is also 2r, and this is also 2r. So you will see this is a equilateral triangle you have, and in equilateral triangle all the angles are 60 degree. 60 degree. Okay. Now if I talk about this force, I will assume the coordinate axis here. This is y-axis and this is x-axis. Okay. So I want to find out, because in this question I have to find out the forces of attraction on any one due to other two. So if I talk about this mass particle, okay, which I have highlighted. So this mass m, which is present here, trying to pull it in this direction. Okay. And this mass, which is on the x-axis, trying to pull it in this direction. Let me just change the color of pen. So this is the forces of attraction applied by this mass, and this is the forces of attraction applied by this mass. Okay. So there are two forces of attraction which is acting on this particle. Okay. So we have to calculate that by the principle of superposition, you can say. So the net force acting on the particle having mass m is equals to the force applied by this mass, let's say this Fm11 plus F applied by this mass m2. m1 m2 are same. Okay. So what is the value of this Fm2? It is easy to calculate because it is present in line, and this line is very straight. Okay. The line has a distance of 2r. So what is this? Firstly, we will calculate this. This is Fm1. The force given by G m1 m2 by r square. Okay. What is the mass? It is m into m divided by, what is the distance between them? It is 2r. So it is 2r whole square. Okay. Now this is gm square by 4r square. What is Fm2? It is also given by this gm1 m2 by r square. What is the value of m1 and m2? m1 is small m and m2 is also small m. So it will become m square divided. What is the distance between them? The line joining the center of them. It is 2r. 2r square. Okay. So we have g m square by 4r square. Okay. If you try to find out the net force, so it is F1 plus F2 by the principle of superposition. Although I am calculating here the magnitude only, so magnitude will come. If you take it as the vector form, so you have to take this force at an angle of 60 degree. Okay. So you have to calculate the component of this line joining them, the vector along this line, and then you have to put it in the equation. So the F net here is F1 is gm square by 4r square, plus F2 is also gm square by 4r square. So it will become 2 times gm square by 4r square. 2 से 2 4 times 2 2 is 4. So it is gm square by 2r square. This is the net force which is acting on this particle. Same amount of force will act in this particle but in different direction. Same amount of force will act in this direction but with a different direction. Okay, got it? I hope you are clear with this, how to find this. Okay. Now, if you have any kind of doubt, you can ask. Immediately you can ask. Okay. So this is it. The topics that we have left with, we will cover in the next lecture. So this is it for my side. If you have any kind of doubt, you can ask. Otherwise, the lecture is over. Thank you so much for being attentive and paying attention. And one thing more that I want to appreciate you, that you are presenting. Okay, you are full in attendance, and that is very good thing. Okay, it will also help you to understanding the each and every concept. Suppose one day you will not come and there is a very important concept that has been taught on that day, so you will miss you will miss that concept. Okay, so this is a loss of yours. Got it? You have to do extra classes, take extra notes, take you are going to take the notes of your friends and all. So it will just, you will just spend your time for your mistakes, है ना? ऐसा नहीं करना अपने को. So be attentive. जैसे आज present हो, हमेशा ऐसे ही present रहना. Do not miss this concept because gravitation is also plays a very important role in JEE Mains and NEET also. Got it? So be attentive and be prepared, be confident. You are the aimers. Got it? So if you have any kind of doubt in this, you can just ask. Otherwise, the lecture is over. Thank you so much, guys, for paying so much attention to the lecture. Okay, and be responsive. If I ask you something, any kind of doubt, you will respond immediately. Okay, you have to respond. Got it? That is how this lecture is being interactive. Okay, got it? So thank you so much, guys. So yeah, thank you so much, Rashmi. Thank you so much, Pushpa. Okay, okay.